Previous video I discussed the queuing problem for single server. Now I am going to discuss the queuing models of multiple server. The model is as per Kendall's notations MMC infinity FIFO. That means the customers or persons are coming to the system following Poisson, but the inter-arrival times follows exponential distribution, and this represents the service time follows exponential distribution, and C represents the multiple server. Multiple server means the server more than one. The capacity of the system is infinity and the queue discipline is fast in fast out. So today I am going to discuss this type of queuing model. The arrival rate is lambda. That means customers are arriving to the system follows Poisson, and inter-arrival times follows exponential at the rate lambda, and the service rate is mu. The server numbers C. Okay, this is the brief of this model, and I will discuss this model through an example. Okay, and before going to the problem, here I have noted the formulas how will compute or you will deal the applications or problems. What is P0? P0 means probability of no customer in the system, probability of no items in the system. I will calculate the formula. Formula is given here. This is the formula. It is a lengthy formula, long formula, but you need not to know how this formula has come, but you have to keep in your memory this formula to apply. Okay, because the formulation part is beyond your syllabus, that is the mathematical statistical part, and Pn means probability of n numbers of persons in the system, and this is the formula I will compute. C is the number of servers. Okay, now this is the expected number of customers in the queue, LQ. I will compute. The formula is given here, and this is for the multiple server. Next, and WQ means the expected waiting time in the queue. In my previous video I have already discussed what is the difference between waiting in the queue and waiting in the system. Now I am not going to repeat it again. If you have any doubt, then you please check the previous video. That means waiting time in the queue and waiting time in the system. This is waiting time in the system, that is both in the queue as well as the time waiting for the service. And LS means, this is LS, is the expected number of customer in the system, LS, and LQ means the expected number of customers in the queue. These are the formulas which you have to apply for solving the problem. Okay, now example, a petroleum company is considering expanding its unloading facility at the refinery. Okay, due to factors such as weather variations, loading delays, and other unpredictable events, ships arrive at the refinery to unload crude oil at a rate of 5 ships per week. This is the arrival rate. That is, the value of lambda is 5 ships per week. The unloading service rate is, that is service rate, is 10 ships per week. Assume that the arrivals follow Poisson process. That means the inter-arrival times follows exponential. That is the theory that I have already discussed. The service times are exponentially distributed. It is given. Now what you have to do? First, you have to determine the average time a ship has to wait before it starts unloading its cargo at the refinery. Okay, in this case the number of server is 1. The second server is not added. Okay, that's why I will calculate it. See, this is the solution. Lambda is equal to arrival rate is equal to 5 ships per week. It is given. Sometimes you will see it will be the time, average time is given, then you have to convert it to the ships, arrival rate ships per week. Now mu is also given here directly, that is the service rate, 10 ships per week. Now if the server is 1, because in this problem the server is being considered as 1, then what is the formula for expected waiting time before service? That is WQ. In my previous video I have shown the formula. Again I am noting here it. The value of WQ will be calculated by this formula, lambda divided by mu into mu minus lambda. Lambda is 5 and mu is 10, and mu minus lambda means 5. 10 minus 5 is 5. That is 1 by 10 week. Here it is a single server. But now say B. If a second unloading berth is added. Second unloading berth is added means what? That means it is a multiple server. That is the number of server will be 2. Added means 1 added means the total number of server is 2. What will be the average number of ships waiting to be unloaded? That is waiting time in the queue. Now you have to apply this formula. First you have to calculate LQ, then you will put this in this formula that I am going to discuss. See, first you have to calculate what, this is the B. With the addition of second berth, the queuing model becomes MM2. MM2 means the 2 servers. 2 berths means 2 servers. First you calculate rho. The formula is this. This is called traffic intensity. Lambda by 2 mu. Lambda is 5 and 2 mu means mu is 10, 20 days. By applying the formula 1 at above, we may write 1 by P0. This is simply the application of the formula. First you find P0 and then put the value of P0 to LQ. The formula, both the formula is given above. You can check it. I am not going to show you. Okay, I can show you that. First applying the formula 1 by P0, you see the formula 1 is this formula. By this formula you can calculate the value of P0, because the C, lambda is given, mu is given, and everything is given. So by applying this you can find out the value of P0. This is given here. You can apply it, and with the application the value of P0 is 3 by 5. Now put this value to the formula L2. This formula is also given, the formula 3 at above. And if you put all the lambda, mu, C means 2, C का value 2 रहेगा. And rho already you have calculated 1 by 4. Just you put and you calculate, then you will get the value of L2 will be 1 by 30. This is the answer for B. Now go to C. With the addition of 2 berths, what would be the average time a ship would wait before being unloaded? Before being unloaded means what? Before being unloaded means WQ. Now see, this is WQ. This is again the formula which I have already noted above. I have already calculated the value of LQ and lambda, you know, to put the value, then the WQ, the waiting time before the unloaded system, is this 1 by 150 week. Okay. Now the last part is what? The formula D. What is the average number of idle bars at any given time? What is the average number of idle bars? See how we'll calculate it. If there is no ship in the system, then both the bars are idle. That is P0. It is probability of no ships in the system. If there is only one ship in the system, then one of the berth is empty and one is being used. Hence expected number of idle berth. What is the expected number of idle berth? This is P0 probability of no ships in the system. That's why this is P0 and the 2 berths are there. This is the expected value. Plus if there is one ship is being unloaded and one is free, not being used, then probability is this. And the expected, that means one is idle, this is the idle, and one ship is used and one is idle, that means 1 into P1. How the value of P1 will be calculated? It is shown here. This is the formula Pn. In place of n, it is written 1 because P1 and lambda by mu to the power 1 factorial P0, the value will be 3 by 10. If you put 3 by 10, 1 into 3 by 10, that is, this is the expected number of idle bars. In this way, you can solve the problem of queue of multiple server. That means you have to know the formula for computing different required items like WQ, WS, what we have done in this case. And just by simply applying the formula, you can solve the problem. Okay. This is the difference between single server and the multiple server. Only the formula is different. How the formulas come, that is the mathematical part. But you should know the appropriate formula. So what you will do at the very beginning, you have to compute the lambda and mu. If it is given directly to the problem, no issues. In this case, it is given directly. It is lambda arrival rate 5 shifts per week and service rate also given directly. But instead of number, sometimes average time is given. In that case, a small formula of 1 by lambda is to be used, and from that you have to compute the lambda. That I have already shown in my previous video. In this way, you can solve the model of queuing, the cases of multiple server. Thank you. If you have any doubt, any question, please note to the comment box and I will definitely reply in a very short span of time. No problem. Thank you. Once again, thank you.